Do you ever stop and ponder about what's beneath our feet? Today we will unveil the Earth's secret layers. Imagine, if you will, our planet as an enormous cosmic apple. It might seem like a strange comparison, but it's a surprisingly accurate one. Just like an apple, our Earth has distinct layers, each with its unique characteristics and functions. So what are these layers? Well, starting from the outside and moving inwards, we have the crust, the mantle, the outer core, and the inner core. Let's take a quick peek at each one of these, shall we? First up, we have the crust. This is the layer we're most familiar with, as it's where we live and play. It's like the skin of the apple, thin and brittle. But don't let its frailty fool you. This layer has mountains, valleys, and everything else that makes our planet's surface so diverse and beautiful. Next, we have the mantle, a thick layer of hot, flowing rock. Picture the flesh of our apple, except it's over 1,800 miles thick and hotter than a pizza oven. This layer isn't solid rock, but rather a slow-moving, plastic-like substance that flows under extreme heat and pressure. Deeper still, we find the outer core, a sea of molten metal. This is like the core of our apple, except it's made up of swirling liquid iron and nickel. This churning sea of metal generates our planet's magnetic field, which shields us from harmful solar radiation. Finally, at the heart of it all, we have the inner core. This is the pit of our apple, a solid ball of iron and nickel. Despite the extreme heat, the immense pressure at this depth keeps the inner core solid. And there you have it, a sneak peek into the fascinating layers of our Earth. Each layer is incredibly different, yet they all work together to form the planet we call home. Now, prepare to take a thrilling journey to the center of the Earth. First stop, the Earth's crust. Do you know it's like the Earth's skin? Imagine it like the skin of an apple, thin compared to the rest of the fruit, but oh so crucial. This outermost layer of our planet, the Earth's crust, is much more than just a rocky surface. It's the land beneath our feet and the bed of the oceans. It's home to the tallest mountains, the deepest valleys, and everything in between. The crust is made up of a variety of elements, with oxygen, silicon, aluminum, iron, calcium, sodium, potassium, and magnesium being the most abundant. These elements combine to form different types of rocks such as granite, basalt, and others. Just like our skin has different thicknesses on different parts of the body, the Earth's crust also varies in thickness. Under the continents, it's typically between 20 and 70 kilometers thick, but beneath the oceans, it's much thinner, averaging about 5 kilometers. Now, here's something interesting. The crust isn't one solid piece. It's actually made up of large pieces, like a jigsaw puzzle called tectonic plates. These plates move and interact, leading to some pretty exciting events like earthquakes and volcanic eruptions. You might think the crust is just a boring, rocky layer, but it's actually a dynamic and ever-changing part of our planet. It's constantly being created at places where tectonic plates are moving apart, like under the oceans. At the same time, it's being destroyed where plates are coming together, like at the edges of continents. So, the crust is not just a passive layer on the surface of the Earth, it's an active participant in shaping the landscapes we see. From the highest mountain peaks to the deepest ocean trenches, the crust plays a vital role in forming these spectacular natural features. So, just like an apple has a skin, our Earth has a crust. But what's beneath that crust? Stay tuned to find out as we continue our journey to the center of the Earth. Beneath the crust, there's a world of rock waiting for us. Welcome to the mantle. The mantle is a thick layer that lies directly under the crust and makes up about 84% of Earth's total volume. Now that's a lot of rock. It's mostly composed of silicate rocks rich in iron and magnesium. These aren't the kind of rocks you'd find in your backyard, though. They're under so much pressure and heat that they behave more like a very thick, slow-moving liquid than a solid. The mantle is divided into two parts, the upper and lower mantle. The upper mantle is cooler and more rigid, while the lower mantle is hotter and more fluid. Together, they form a dynamic, flowing sea of rock that's always moving, albeit very, very slowly. We're talking millions of years here. Now you might be wondering, what's the big deal about this world of rock? Well, it plays a crucial role in shaping the Earth's surface. How, you ask? Through something called plate tectonics. The heat from the mantle creates convection currents that make the tectonic plates on the Earth's surface move. This movement can cause earthquakes, volcanic eruptions, and even create mountains. So the next time you feel the ground shake or see a volcano erupt, you'll know it's the mantle at work. But the mantle isn't just about destruction. It's also a creator. When the mantle's rocks melt, they form magma. This magma can rise through the crust and cool to form new land. That's how islands like Hawaii were formed. So, the mantle isn't just a world of rock, it's a world of creation and transformation, always changing and shaping the world above it. Wow, the mantle sure is fascinating, but we've only just begun. Scene script. Next, we plunge into a sea of liquid metal. Here's the outer core. Just imagine being surrounded by a swirling, shiny mass of molten iron and nickel. That's right. Earth's outer core, the third layer from the surface, is not a solid but a vast, scorching sea of liquid metal. It's like the world's largest cauldron of molten fondue. But instead of cheese or chocolate, we're talking about a blend of metals heated to mind-boggling temperatures. Now, you might be wondering, why is it liquid? The answer lies in the intense pressure and heat from the layers above. The outer core is squeezed by the weight of the mantle and the crust, but it's also heated from the inside by the inner core. This unique combination of pressure and heat creates a molten state. But the outer core isn't just a giant simmering soup of liquid metal. It's also a key player in a very important function of our planet. Have you ever played with a compass and noticed how the needle always points north? Or maybe you've heard about birds and sea turtles using the Earth's magnetic field to navigate their long-distance migrations. Well, we have the outer core to thank for these phenomena. As the molten iron in the outer core moves and flows, it generates electrical currents. And these currents, in turn, create a magnetic field that extends far beyond the planet's surface. This magnetic field acts like a giant shield, protecting us from harmful solar radiation. Without the outer core's liquid motion, we wouldn't have our life-saving magnetic field. But the outer core isn't just fascinating because of its composition and function. It's also a reminder of just how dynamic and constantly changing our planet is. Even thousands of miles beneath our feet, there's so much activity and movement. The outer core is like the Earth's fiery heart, but what lies at the very center? We'll dive deeper into that mystery in the next segment. Remember, the journey to the center of the Earth is full of surprises. Finally, we reach the Earth's solid center. Welcome to the inner core. This sphere-like structure is the deepest part of our Earth, made mostly of iron and nickel. Not only is it solid, but it's also incredibly hot, with temperatures close to those on the surface of the sun. Now you might be wondering, why is it solid if it's so hot? Good question. Even though the temperatures are scorching, the immense pressure at the core keeps it from melting. The inner core plays a crucial role in Earth's structure. It's the engine that drives the magnetic field surrounding our planet, protecting us from harmful solar winds. So imagine the Earth as a giant peach. The inner core is like the pit, providing support and stability. It might be the smallest layer, but its role is mighty. The inner core is the final stop on our journey. But what have we learned? So we've journeyed from the Earth's crust all the way to its inner core. We began our adventure at the outermost layer, the crust, a thin, cool shell that's home to all life as we know it. Then we plunged into the mantle, a world of rock where temperatures rise and pressure squeezes. We descended further into the outer core, a swirling sea of liquid metal, generating the Earth's magnetic field. And finally, we reached the heart of our planet, the solid inner core, a giant ball of iron and nickel under extreme pressure and heat. Each layer plays a crucial role in shaping the Earth's structure and maintaining its life-supporting environment. They are the hidden foundation of our world, silently working to shape mountains, stir oceans, and even direct our compass needles. Remember, even though we can't see them, these layers are beneath our feet every day, making our planet a wonderful and diverse place to live.